All right, let's do this. Okay, so nonlinear inequalities means that we're going to be dealing inequalities with degrees that are higher than obviously 1, because that would be linear. And we're also going to be dealing with rational functions today. Okay, so do you remember what it is, what an inequality is?
Less than, greater than, less than.
Good. So we're going to have equations, and instead of having them equal to something, we're going to have them either be greater than, greater than or equal to, and less than or equal to some number. Okay? Now, here's the key to solving these types of problems. You're going to treat them as if they were equalities. So in other words, as if you had an equal sign. Okay? It's got just one extra step we're going to have to do because we do not have an equal sign in it. Okay? Now, what is the first thing you must make sure that you have in order to solve an equality? Forget an inequality. Okay? Like if it's equal to, what do you need to make sure that you have before you begin the problem?
Variable.
Well, they gotta have a variable, but what do you do in order to start solving? Before you even before you begin to try to solve for x, you need to make sure that this is true. Or what do you gotta do before you begin? Okay, we gotta set it equal to 0, guys. You guys did that just last chapter. Before you began solving for the zeros or anything, you set it equal to 0 before you can solve, right? So same thing for inequalities. You're gonna set it equal to 0. After you set it equal to 0, what do you do? Okay, I guess it's Monday. It's all good. We're gonna factor. Okay, we're gonna factor. Once you factor, you find all zeros. Once you find all zeros, this is what's new because it's an inequality. Because it's an inequality, you are going to create a number line using the zeros. And lastly, you are going to test a number from each interval. And I guess we can add an extra step, which would be to analyze number line and answer question. Okay, so this would be your, I guess, your recipe for success for inequalities. Okay, we're gonna start out with polynomial inequalities since that's what this chapter started out with, polynomials. So let's start out with something very easy. Okay, so example number 1, we're gonna solve the following. We have x squared minus 2x minus 8 such that you are less than or equal to 0. Okay? Alright, so our step 1 is done. We are equal to 0. Step 2 is we're going to try to factor this. So, in this case, it's a very simple quadratic. So we got x and x. I need two numbers that multiply to be 8, but add up to be a negative 2. So that's going to be a negative 4 plus a 2. Okay? Now we're going to come up with x equals to 4, x equals to negative 2. With these values, you are now going to create a number line. So that number line is going to look something like this. We got a number line. I'm going to include those values in order. So negative 2 comes in, and then 4 comes after that. What you have done now is you have broken up a number line into 3 intervals. There is an interval between negative infinity to negative 2, negative 2 to 4, and then 4 to infinity. What we need to figure out is, at these zeros, where am I? Am I above the x-axis or am I below the x-axis? Okay, so to do so, I am going to use my knowledge from chapter 2 to speed this process up. I know that this quadratic, if I were to look at the graph and I were to graph that, based on the leading coefficient and the power, it would have an end behavior of rising on the right and the left. Now, based also on the zeros that I found, I would have a 0 here at negative 2. I would have a 0 at 4. They both have a multiplicity of 1, which means that when I arrive at them, I need to cross. I need to turn around. I need to cross. And then this quadratic should look something like that. Okay? Now, I'm going to utilize this graph to analyze the situation. So before -2, I'm above the x-axis, which means those are positive numbers. Between -2 and 4, I'm below the x-axis, which means those are negative numbers. And after 4, I'm above the x-axis, which is positive numbers. So now that I've filled out my number line, I can answer the question. I can analyze this number line and ask myself, when is this expression less than 0? Less than or equal to 0, I'm sorry. Well, that would be when you are below the x-axis or in the number line where you are negative. So in this case, the answer is going to be between -2 to 4, including the endpoints. Or you can write it like x is less than or equal to 4, but greater than or equal to -2. Either one of this is going to be acceptable. Okay? All right. For the rest of the problems, I'm not actually going to graph them. I'm going to utilize this, my knowledge of graphs, to come up with what's happening here. Any questions before I keep going? Okay, sweet. Example number 2. I have x squared minus 4x such that you are less than 12. Okay, so first step, we're going to set this equal to 0. Second step is I'm going to try to factor this out. So this would be x, and let's see, minus 6 and plus 2. So that gives me x equals to 6 and x equals to -2. I'm going to go ahead and create my number line. So we've got -2 and 6. Once again, I'm going to use end behavior to help me out. So this is positive and even, so it's going to be rising on the right and the left, so it's going to be positive numbers on the right and the left. And then the multiplicity of these are 1, which means I'm going to have to cross the x-axis, which means this is going to be negative. So therefore, if I interpret my number line, this is going to be, once again, this middle part. But this time, I am not including the endpoints because I am just less than. Cool. So you can either write that, or -2 is less than x, which is greater than, which is less than 6. Okay? All right. Example number 3. (2x to the third power minus x squared such that you are greater than or equal to -2x plus 1. Step 1, let's set it equal to 0. So 2x to the third minus x squared plus 2x minus 1 such that we are greater than or equal to 0. We're going to try factoring by grouping on this example. So we're going to group that and that. From the first grouping, I can take out an x squared, which would leave me with a 2x minus 1. From a 2x minus 1, I can factor out a positive 1. Therefore, this factors out to become x squared plus 1 times 2x minus 1, which is greater than or equal to 0. Okay, so I'm going to set each one of these factors equal to 0. This is going to give me x equals plus or minus the square root of -1, and this is going to give me x equals to 1/2. Square root of -1, you must remember that that is I. It's an imaginary number, therefore it is not going to show up on my graph, which means it is not going to affect my number line. So I am not going to include this on my number line. I'm going to go ahead and just include the number 1/2. Once again, I'm going to use end behavior to help me out. This is a positive leading coefficient with an odd power, which means I am going to be rising to the right, which would be positive numbers, and falling on the left, which would be negative numbers. Based on this number line, I need to answer the question, which is when am I greater than or equal to 0? In this case, I'm going to be greater than or equal to 0 from 1/2 to infinity. So it is going to be 1/2, including 1/2, towards infinity. Or if you want, you would have to say x is greater than or equal to 1/2. All right, guys, how are we doing? Questions thus far?
No, it seems pretty good.
Awesome. Okay, on the next few examples that I'm going to do, I'm going to talk about unique situations. So I think these first three examples hopefully have been pretty straightforward for you. Finding the zeros and factoring has been relatively simple. The next few examples are going to be a little bit more, not challenging as far as factoring and finding the zeros, but you're going to have to really analyze your number line. Okay, let's go ahead and get started. So let's do another example. Alina, I just saw your message. You're good. I got you. All right, so example number 4. We've got x squared plus 3x plus 10 such that you are greater than 0. Okay? All right, so once again, it's equal to 0. We're going to try to factor this out. So is there two numbers that you can think of that would give you a 10 but would add up to be a positive 3? Well, in this case, I mean, the only numbers I can multiply to 10 would be 5 and 2 and 10 and 1, which, well, 5 and 2 could combine to be 3 if one of them was negative, but if one of them was negative, then this would have to be negative. So in other words, this is not factorable, which means we're either going to have to find the zeros through the quadratic formula because this is a quadratic, or by completing the square. By this point, you have practiced the quadratic formula quite enough, so I'm going to start using completing the square because to me that's a lot faster. Okay, so what I'm going to do is I'm going to complete the square. So it'll be x squared plus 3x plus some number that I need to find. I'm going to bring the 10 over to the other side by subtraction, and whatever number I find here also has to be on the other side. So remember, to complete the square, first of all, this has to be a leading coefficient of 1, which it is. We take this value in front of x and divide it by 2. So 3 divided by 2 would be 3/2, and you square it. 3/2 squared would be 9/4. So 9/4 would go there, and 9/4 would go there. This is now a perfect square, and this factors out to be x plus 3 over 2 squared, which is equal to, now think this through, negative 10 is the same thing as negative 40 over 4. So negative 40 over 4 plus 9 over 4 would be negative 31 over 4. At this point, I'm going to be able to take the square root of both sides. So that gives me x plus 3/2 is equal to plus or minus square root of 31 divided by 2i. Now I'm going to go ahead and stop there because I realize, I mean, I can solve for this, but at this point I realize that this is imaginary. Both of my answers are imaginary, which means that when I create my number line, I don't have a number to put because it's all imaginary. So that gives me one idea, really, that's happening with this. Either this quadratic is completely going to be above the x-axis, or it's going to completely be below the x-axis. So in order for me to figure that out, all I need to do is figure out the end behavior, which in this case is going to be rising on the left and rising on the right, which means that this entire quadratic is completely above the x-axis for its entire domain, which means that this thing is going to be greater than 0 for its entire domain, which means that my answer is going to be from negative infinity to positive infinity, or you can say all real numbers. Any questions on that one? It was a little different than what we've done. Do we understand why it would be all real numbers?
But would it be all real numbers because it's just above the horizontal axis?
Yeah, so if we actually grab this, guys, like, actually, what I do know is that, I mean, this is not the exact sketch, but this is going to look something maybe like that. So it's nothing, like you're not going to touch the x-axis. You're never going to be below. So if we're looking for when are we greater than 0, then you're always greater than 0. Cool?
Oh yeah, because it kind of relates to the y. Yeah.
Exactly. Good.
Yeah.
All right, example number 5. All right, let's say that you have x squared plus 4x plus 4 such that you are less than or equal to 0. Okay? All right, so once again, we're going to try to see if we can factor this out. And this looks like to be a perfect square to me, so this is going to be x plus 2 times x plus 2, which means that you have x is equal to negative 2 as your 0. Okay? And this is important. I'm going to go ahead and use my knowledge of multiplicity. So this has a multiplicity of 2. Okay, so that's the only number that I have on my number line. If it's positive leading coefficient with an even power, that's going to be, I'm going to be rising on the right and rising on the left. So that means it's going to be plus plus. And it should make sense, because if we were to grab this, and we have the end behavior to be this, and we have negative 2 as the only 0, with a multiplicity of 2, what I do know is that when I get there, I have to touch and then turn right back around. So that definitely does match the behavior that I have here on the number line. So now this is where you have to actually look at your number line and analyze it. I am looking for when is this less than or equal to 0. So based on my number line, am I ever going to be less than or equal to 0?
No.
Analyze it, look at it. I do have a solution. Where?
Yeah, it's equal to 0 at negative 2.
So that means that your solution is x equals negative 2. And that's only because this says less than or equal to. Now, are you ever going to be less than? No. But since we are equal to 0, 1 location, we have to include that solution. Questions about that, guys? How are we doing so far? Okay, I'm going to take silence as we understand what's happening. So, I mean, we've gone over 5 examples. I can do way more of this. Notice that I did a lot of quadratics. It's not that you're only going to be dealing with quadratics. I just wanted to come up with unique examples to show you the different situations. You're going to be dealing with polynomials of 2nd, 3rd, 4th degree, okay, on your homework. So, as far as polynomials, I think this kind of covers all the scenarios that you can run into. With polynomials, definitely use your knowledge of multiplicity and end behavior to help you figure your intervals out, okay? So now we're going to go ahead and move on to rational functions. All right, so for rational inequalities, we're going to go ahead and set up, again, a kind of a set of steps to follow. Number 1 is going to be to set equal to 0. Number 2 is still to factor. But number 3 is going to be a little different. So for polynomials, we would just find the zeros. But for inequalities, you're going to find your zeros, your vertical asymptotes, and your wholes. Then you're going to create a number line using the information above. You're going to test values, and then you're going to interpret results. Okay, so the only difference is that now for rational inequalities, you are going to have to find vertical asymptotes and wholes. Okay, other than that, the process is going to be very similar, with the exception that we're no longer going to be able to use the idea of end behavior to help us out, because we are no longer dealing with a polynomial. So this idea of testing the values is going to be different. Okay, and I'll demonstrate to you what I mean by that. Okay, so let's go ahead and move on to example. I think we're on number 6 by now. And this time we have an inequality. We're going to start out with a simple inequality. We've got x minus 5 divided by x plus 2, such that you are greater than or equal to 0. All right, so first thing is we're going to set it equal to 0, which it already is. Second thing, we're going to factor. It's already factor. Third thing is, can you find the zeros, the vertical asymptotes, and the wholes? Okay, so we have a 0 at x equals 5 and a vertical asymptote at x equals negative 2. So I'm going to go ahead and make a number line with this. So here's negative 2 and here is 5. This time what you are going to do, guys, is you're going to have to actually find a number that's in these intervals and plug it into this equation to figure out whether you are going to be positive or negative. we don't really care about what the number is. We just want to care if we only care if the number is positive or negative. So I'm going to go ahead and pick out some values. So before -2, I'm going to try -3. So if I plug in -3 right here, that gives me -3 minus 5 over -3 plus 2. Okay, so -3 minus 5, that gives me -8. -3 plus 2 gives me a -1. So -8 divided by -1 gives you a positive 8. So all I care about is that I get a positive number. Okay? All right, now I'm going to try the number 0 between -2 and 5. So if I try 0, I'm going to go ahead and write it here. So that's going to be 0 minus 5 over 0 plus 2. That gives me a -5 over 2. -5 divided by 2 gives you a negative number, and that's really all I care about. And lastly, I'm going to pick a number after 5, which I'm going to choose for this case 6. So 6 minus 5 over 6 plus 2. 6 minus 5 is 1. 6 plus 2 is 8. That gives me a 1/8, but I don't really care about the 1/8. I care that it's positive. So based on this, now I have my number line, and I can analyze it just like I did before. I am looking for when is this interval greater than or equal to 0. Based on that is wherever the positive symbols are at. So what I do know is that I'm going to go from -infinity to -2 and from 5 to infinity. The question that I have for you is, where do I use parentheses and where do I use brackets and why?
I think you'd use brackets for everything because I don't think it includes -2. Because I think I tried plugging it in and you would get 0 in the denominator. So if you divide by 0, it's under 5.
Got you. So I think you said brackets, so then you mean parentheses. Because
Yeah,
brackets would be to include. Okay, so we're actually going to use parentheses everywhere except for the 5. The 5 should work. Okay? Now, we're going to use a parenthesis here for the exact same reason that you said. If we use -2, that's going to give us a -2 in the denominator, which we cannot have. If we use the 5, that gives us a 0 in the numerator, which definitely can happen. Now, so that you don't have to analyze that much, notice, here's what I recommend. Notice how over here I kind of label things where I said 0 and then vertical asymptote. You know, based on our last lesson, that you cannot touch a vertical asymptote. So that is the reason. The moment that you see, okay, I have a vertical asymptote, I automatically am going to have a parenthesis there. Cool? So this would be our solution in interval notation. The other way that you can say this is that x would have to be less than -2. So it would have to be less than -2 in order for this to work. Or x would have to be greater than or equal to 5. So either way that you want to answer this question, I'm okay with the interval, or I'm okay with the actual using the variable of x. Cool? All right, questions about the rational inequalities, because I honestly just have maybe one more example and that would be it for today. So do we understand at least the steps to get through this? Cool? All right, so let's go ahead and do one last example. It's going to be a little bit more elaborate, and that will be all for today. Okay? So example number 7. Same thing, we're going to solve the inequality. We have x plus 12 divided by x such that you are less than or equal to 7. All right, what do we think?
Bring 7 to the left.
Yeah, we're going to go ahead and bring 7 to the left, so we're going to have x plus 12 over x minus 7 such that we are less than or equal to 0. Now what? This is where you got to think this through. So we're dealing with rational inequalities, okay? You have 3 terms. It's not a polynomial because this one's divided by x. So because it's not a polynomial, I need to make this entire thing look like a fraction. Or in other words, I need to make it rational. In order for me to do that, I need to get this, this, and this on the same denominator, which should be, I need to multiply this numerator and denominator by x, and so for this one. So what that does for me is now I have a common denominator. I'm going to have x squared minus 7x plus 12 divided by x such that I am less than or equal to 0. Did I lose anyone on that step? We're good? Okay, we're going to go ahead and try to factor this out. So numerator-wise, I should be able to factor this into x minus 4, x minus 3. Denominator is just x, so that's not terrible. So now at this point we know, okay, we have zeros at x equals 4 and 3, and then we have a vertical asymptote at x equals 0. So when I create my number line, I'm going to go ahead and put these things in order. I have 0, I have 3, and then I have 4. I personally, so I don't forget, I'm going to go ahead and kind of highlight 0 because that's going to be a vertical asymptote, which means I'm not going to be able to touch it. So I need to keep that in mind. So I'm going to go ahead and start testing numbers out. So before 0, I'm going to try -1. So what I'm going to do is, instead of going all the way back to this expression, I'm going to test it on the factors form. So I have -1 minus 4. So -1 minus 4, that gives me a -5. -1 minus 3, that gives me a -4. And then all of that would be divided by a -1. Okay? Now, -5 times -4 gives me a +20. Divided by a -1 will give me a -20. But all I care about is that it is negative. Okay? All right. A number between 0 and 3 that I can use would be 1. 1 minus 4 would give me a -3. 1 minus 3 would give me a -2. And then just a 1 on the denominator. -3 times -2 gives me a +6. Divided by a +1 produces a positive number, which means that between 0 and 3, everything is going to be positive. And now for the rest of this, I am going to use my knowledge of multiplicity. How many times did each one of these zeros show up? One time, which means you have to cross, right? So if you're at the positive numbers before 3, and you know that you have to cross at 3, then that means that this has to be negative. And then if you're in the negatives, and you know that you have to cross at 4, that means you have to go to the positives. If you don't feel comfortable with using that technique, you can always pick a value between 3 and 4 and it's going to match. So a value between 3 and 4 would be like 3.5, right? So 3.5 minus 4 would give you a -0.5. 3.5 minus 3 gives you a +0.5. And then that would be divided by a 3.5. Negative times positive gives you a negative number. Divided by a positive gives you negative. Cool. And same idea with after 4, I could use 5. 5 minus 4 gives me 1. 5 minus 3 gives me 2, divided by 5. 1 times 2 is positive. Divided by +5 gives you a positive. Okay? So either technique works. I have my number line. Now I can analyze it. So I am looking for when I am less than or equal to 0. So that would be wherever I have negative symbols, which in this case is going to be -infinity to 0. Both of them with parentheses because the 0 is an asymptote. And between 3 and 4, both of those with brackets because I can actually be equal to 3 or 4. Or if you decide to write it the other way, you would have to say that x has to be less than 0 and less than or equal to 4, but greater than or equal to 3. And that should be the solution for our last rational inequality. Okay? All right, so we went over about, I think, 7 or 8 examples. We've covered both polynomials and rational functions. Those are the only types of functions that you're going to be covering on your web-assigned homework as well as on the upcoming tests. Do you have any questions about what we covered today?
Well, Mr. Carrion, there's nothing to infinity.
Say that one more time, I'm sorry?
There's nothing to infinity? Like I thought you'd do like, then include 4 and go to infinity. Right?
No, because this time, look, we're looking for less than or equal to 0, which is a negative value. So after that, it will be positive. Cool?
Yeah. Yeah.
All right, anything else, guys? All right, so I was actually recording this video, so I'm going to go ahead and stop that recording.